Hello everyone, welcome to this video, Deploy Docker image to Azure Kubernetes Service using CI/CD. So first, I will give a quick introduction about Kubernetes so we understand what is Kubernetes in very quick introduction. Then we will understand what is the main component of Kubernetes, which is the pod, and then the node. After that, I will give a quick introduction about Azure Kubernetes Service, AKS, and how to work with Kubernetes with and without Azure Kubernetes Service. Then I will give introduction about Azure Container Registry for those who are not familiar with Container Registry. Then we will go for what is the demo workflow. So I created an animation about the steps and what will happen in the demo so we can understand it, so we can understand the demo better during the demo. So in the demo, the first step is I will create an Azure DevOps project with a sample web application, which has a front end and a back end with API and a SQL Server database, which will be deployed on Azure SQL Server. Then I will install Azure Pipeline Kubernetes extension. This extension will be used to deploy the Docker image to Azure Kubernetes Service. After that, I will create a container registry as a private container registry so we can deploy our image to that container registry. Then I will create an Azure Kubernetes service. After that, I will create Azure SQL Server and Azure SQL Database. All of the creation of these services will be using the Cloud Shell. Also, we can create that using the command line interface or PowerShell. After that, I will configure the Azure build pipeline so we can pull the image from the public registry and then building our application, deploying the application to the image, and then push the image to the private registry. Then we will configure the Azure pipeline for the release pipeline to deploy the DAG pack or the database to the Azure SQL Server and also push the Docker image to the Azure Kubernetes Services. Then we will run the build and the release pipeline and examine the web application which will be deployed to Azure Kubernetes Service. Then we will navigate to the Kubernetes web dashboard for the Kubernetes cluster so we can see how we can look at the Kubernetes cluster from the web dashboard. We will also get the chance to look at how we can monitor the Kubernetes cluster from Azure portal, how we go for the pods and nodes and containers, as well as how we can upgrade or scale, and also how we can do that from the command line or the Cloud Shell. But let me first give you a quick introduction about myself. My name is Mohammed Radwan. I'm a developer technologies MVP and principal DevOps consultant. I have been doing software development for more than 15 years now, worked on several projects for different enterprise customers across different regions and countries. I heavily participated in the community, developed several frameworks, presented many sessions, holding various certificates for Azure and DevOps. I started back in 2002 as a classic ASP developer, relocated multiple times in multiple countries, worked with several technologies and for different roles and positions. And for the last 8 years, I moved to consultancy-based role where I focused more on helping different companies, some of them from the Fortune 500, to improve their software development and delivery using DevOps and automation. I have developed and authored several frameworks, command line tools, and guides. You can find them on GitHub and Azure DevOps Marketplace. I like to share my experience. This is why I have a YouTube channel and blog where they have hundreds of videos and posts that share different topics from my real experience. I have presented many sessions in several user group conferences, events, and customer site as well in different countries. So I got the chance and the opportunity to work in different culture, project size, and company size as well, which helped me to have different experience. Here are some links for my activities. So what is Kubernetes? Kubernetes is an open source orchestration containerization system for automating deployment, scaling, and the management of containerization application. So it deploys your application quickly and predictably, improves reliability because it continuously monitors and manages your container. It will scale your application to handle changes in the load on the fly as needed. So, it will be utilization for the resources and of course for the cost. Better to use the infrastructure by limit the hardware usage to the required resources only, which help reduce the infrastructure requirement by gracefully scaling up and down your entire platform. It also coordinates what containers run where and when across your system. How do all the different types of containers in a system talk to each other? So it handles all the communication between the containers. It also easily coordinates the deployment for the system, which containers need to be deployed and which should be and where should the container be deployed. So it is which and where. So which give at the end a huge capabilities for portability, extensibility, and self-healing. So let's understand in more details what is a pod. So the pod is the core Kubernetes component. So it is a Kubernetes abstraction that represent a group of one or more application containers, such as Docker or any containerization technology, and some shared resources for those containers. Those resources include shared resources as volume, as we can see in the picture, networking as a unique cluster IP address, information about how to run each container, such as a container image version or a specific port to use. So it's an abstraction for the entity. So for example, as we can see, we have one pod with one container and IP. We have another pod with one container and one volume, and the third one with two container and one shared volume, and the last one with multiple containers as well as volume. As a summary, pods are the atomic unit on the Kubernetes platform. When we create a deployment on Kubernetes, that deployment creates pods with container inside them. As we understand now that container must wrapped in a pod run on Kubernetes, to get more details, what exactly inside the pod is an isolated area of host OS, network stack, and a bunch of kernel namespaces that able to run one or more containers in it. Pods are also the minimum unit of scheduling in Kubernetes. So for example, if I want to scale the application by adding or removing pod, not by adding or removing containers. A single pod can only be scheduled to a single node, regardless of the number of containers it wraps. Let's look at the node. What is the node? A pod always runs on node. A node is worker machine in Kubernetes. And may be either a virtual machine or a physical machine, depending on the cluster. Each node is managed by the master. This is why we have a master and we have the agent. It's like a controller. So a node can have multiple pods, and the Kubernetes master automatically handles scheduling the pods across the nodes in the cluster. The master atomic scheduling takes into account the available resource on each node. This is why it's master, because it's mastering which pod run on which node and managing the orchestration of the pods and the nodes. So as we can see, Kubernetes operates on a cluster of nodes. And as we can see, each node can run different containerization platform. For example, it could be Docker, it could be other containerization. So nodes where application service run and provide the data plane. Each node operates a container runtime, as we explained. A cluster also contains one or more masters to operate the control plane. Scheduling decision, for example, monitoring, implement a change, response to event, and so on. So let's understand what is the Azure Kubernetes Service. Azure Kubernetes Service is the quickest way to use Kubernetes on Azure. It manages your hosted Kubernetes environment, making it quick and easy to deploy and manage containerized application without container orchestration expertise. And this is the main point. You don't need to be an expert in orchestration of containerization to work with Azure Kubernetes Services. It also eliminates the burden of ongoing operations and maintenance by provisioning, upgrading, and scaling resource on demand without taking your applications offline. One of the biggest advantages to use AKS is that instead of creating resources in cloud, you can create resources and infrastructure inside Azure Kubernetes cluster through deployment and service manifest files, which is a YAML file. And we will see that how we will create a load balancer using the YAML file as a part of the deployment pipeline in our demo. So Azure Kubernetes Service bring a lot of capabilities, like for example, automatic ping backing, self-healing, horizontal scaling, service discovery and load balancing, automated rollouts and rollback, secret and configuration management, storage orchestration and patch executions, and many others. So let's understand how Kubernetes work with and without AKS. So without AKS, we will find that we have the control plane, we have multiple masters and with multiple nodes, and we need to manage this master which is controlling the orchestration of the agent pool. But Kubernetes with AKS, we have a hosted control plane on Azure, which will provide a very high abstraction to work with Kubernetes. So for example, there is no master nodes to manage or pay, automated upgrade and patching, easy upgrade control plane and worker nodes to new version of Kubernetes. Scale agent pool to increase or decrease the capacity as needed. So let's talk about Azure Container Registry. The Azure Container Registry allows you to store images for all types of container deployment with different technology of containers, including Docker and Kubernetes and Azure services, such as App Service, Patch Service, Fabric, and others. Azure DevOps helps Azure Kubernetes Service in creating Docker image for faster deployment and reliability using the container build option. The main idea here that we will have a full integration with Azure Pipeline, Azure Container Registry, and Azure Kubernetes Service. So we can push the image to the Container Registry and then deploying that to Azure Kubernetes Services using Azure Pipeline. So let's see the steps and the workflow in the demo in animation so we get more familiar and understanding of the demo. During the demo, we will create main 3 resources using the Cloud Shell. The first is the Azure Container Registry, which will hold the images, and will be the private one. The second is Azure Kubernetes Service. The Docker image will be deployed to pods running inside AKS. Also, we will create an Azure SQL Server and the Azure database. Let's see the workflow. We will start the demo by creating some resources from the command line, but we will use the Cloud Shell. So first, we will declare a variable to get the latest version of the Kubernetes. Then using the CLI to create Azure Kubernetes Service using the variable. So we will create AKS with 2 pods and 3 nodes. After that, we will create Azure Container Registry, then Azure SQL Server and the Azure database. Of course, all this infrastructure, it could be created as a part of the release pipeline, but this is not in our case or not in our scenario. So usually it starts when the developer commits the changes to their local machines. And once they are happy with the change, they start pushing this change back to the remote repo, where this will usually throw a pull request where it triggers usually a continuous integration pipeline to validate the pull request. Once the pull request is merged, this triggers the main continuous integration pipeline. And this pipeline, of course, compiles the application, run the unit test, validate all the quality gates, and then connect to a public registry where it pull an image, a Docker image with .NET Core, and then deploying the application to that image. Once the image has the application, then the pipeline start deploying or pushing this image to the private registry we created at the beginning. Once the image is published or pushed to the private registry, then the release pipeline trigger. The first step that it will deploy the database using the DAC pack, which is part of the package on the Azure DevOps repository. Then after that, it will communicate with Azure Kubernetes Service to make Azure Kubernetes Service communicate with the Azure Container Registry to pull the image. This is why we need to have a communication between Azure Kubernetes Service and Azure Registry. And this is very important because we need to have an authentication between the AKS and the container registry. This will be by creating a role assignment. During the creation of Azure Kubernetes Service, there is a generated service principal behind the scene. And so we will get this service principal ID and then the registry container registry ID, and we will create an assignment role so AKS can have access to the Azure Container Registry and then can pull the image, which will be orchestrated by the release pipeline. Once the image is deployed to Azure Kubernetes Service, the web application will run on the front pod and the backend or the API will run on the backend pod. After that, the pipeline will create a load balancer, which will be along with the front pod. And then from the command line on the Cloud Shell, we will run a command. Then from the command line on Cloud Shell, we will run a command to get the IP of the pods. And then we will get the IP of the front end and then access that from the browser, which will load the web application. We can also have another approach for how to deploy our image to Azure Kubernetes Service by making the release pipeline, pulling the image from the registry, and then deploying or pushing the image to Azure Kubernetes Service. The main idea here is our goal is that we pulling the image and pushing the image to the Azure Kubernetes Service. And this will be covered by the CD pipeline, not by the CI pipeline. Let's look at the actual demo. You can watch this video for more information about Docker, containerization, and where and how Docker can fit with DevOps and CI/CD pipelines. I have created an empty organization on Azure DevOps called Azure DevOps Sessions. So let's navigate to the organization and see the projects. If we go for organization settings, we can see that projects, there is no project. Go to extensions, no extension. Let's go for the root and then open the demo generator project, then sign in. I will select the organization, Azure DevOps Session, and then here I will type the name of the project, which will be MHC, My Health Clinic. Choose the template, DevOps Lab, and I will choose the Azure Kubernetes Service. So as we can see, we need to install two extensions for this project. So the first extension is Kubernetes extension, which will be used or making Azure Kubernetes Service pull the image from the Azure Container Registry. And the second is replace token, which will replace some configuration in the app settings as well as the YAML file. Let's open the two extensions to install them. Get it free. And the same. Choose the organization. Install. It's completed. Close this tabs. Then I will refresh. Unfortunately, I need to do the steps again. So I will type here MHC. Choose the template, AKS. Then, as we can see, the two extensions are installed. So let's now go for the organization projects. We don't have the project yet. Go for the extension. This is the two extensions that we installed. Then navigating back to the project, this is the creation of the project. You can see the progress. Creating two teams, border column, swim lanes, build the definition, release definition. Now it's completed. Let's close that. Navigate to projects, So we can see our project created, go for the root. Here is our project. So now we have our project. Let's go for the Azure portal. So this is my current resource groups. Let's refresh. Then I will open the Cloud Shell, select the organization and the domain. First, because this is the first time to run the Cloud Shell, then I need to create a storage so the Cloud Shell can run and store temporary files. So I will create the storage. Once it's completed, if I get back here and I can see that I have Cloud Shell storage Western Europe, this will be my storage to store the temporary file for the Cloud Shell. Let's get back to the Cloud Shell. This is the main services that I will create them right now from the command line, as I explained in the demo workflow. As I explained, I will create a variable to get the latest version of Kubernetes. Now I can echo the version, the variable, to see what is the version. So as we can see, it 1.13.5. Then I will create a resource group to hold the Azure Kubernetes Service. The resource group created. Let's navigate back here, refresh. So as we can see, this is our resource group, which is an empty. Then I will create the Azure Kubernetes Service now in this resource group. So here, as we can see, create the resource group, giving the resource group name, and then the AKS name, which is unique name. This is why I put my name, and enable monitor. And this is very important because at the end of the demo, I will show you how we can see the monitoring capability and the performance of the nodes and pods and containers. You can watch this video for more information about gateways animation. You will see different animated commands like branch, merge, rebase, cherry pick, and many others. This will take time. It could take around 15 minutes to create all the services. As we can see, the service principal created. This is automatically created during the creation of the AKS. And we will use this service principal to create a role so we can have access to Azure Container Registry. So let's refresh here. So as we can see, there is other resource group created. Here we can see the AKS created. If we go for other resource group, we can see here the monitor capabilities. And here will be the nodes. It will be created with 3 nodes or 3 virtual machines, as we will see. Let's refresh, still creating them. Yes, so as we can see here. So again, after some time, as we can see, the machine is created. So waiting to the rest of the completion. Now it's completed, all the AKS created. So if we get back to the Azure, let's refresh. Then go to the resource group. It's completed now. Let's see any new resource. Here, all the nodes and the agent pool created. So if you can see here, sorted by type, we can see we have 3 virtual machines which work as an agent pool for the nodes. So let's get to the Azure Cloud Shell. And then we will create the Azure Container Registry to hold our image. So this will create Azure Container Registry. Now it's created. Let's get back and refresh here. So yes, as we can see, it's created. Get back here. Here we are going to grant AKS generated service principal access to Azure Container Registry. So first we will get the ID of the service principal, then get the ID of Azure Container Registry, then create role assignment using both of them. So here I will get the ID of the service principal in this variable, and here I will get the ID of Azure Container Registry. Then I will create the role assignment. Now it's created. Let's clear the screen so we can see the command. So here I will create the Azure SQL Server. Let's get back to refresh here. Still create. Now it's complete. If I refresh here, we can see the SQL Server created. And then I will create the database. Now the database completed. If I refresh here, also we can see that the database completed. So if I open the database to see the name of the SQL Server, because we will use it through the build and deployment. And here also, if I open the Azure Container Registry, I can see the login server. Let's navigate to our project and go to the pipeline, the build pipeline, and click edit. This is the build tasks. So we need to have a communication between the Azure pipeline and the Azure Container Registry. This is why I need to authorize Azure Pipeline to have this communication. And I will do that by selecting from here my subscription, which will add a service principals with the endpoint to my Azure subscription. So I will log in using my credentials. Once I complete the login, I can have authorized to my Azure subscription. And then from here, I can select the Azure Container Registry for all the build tasks. It will be the same. Now I go for the variables to replace the variable here, the Azure Container Registry variable. So I will go for Azure Portal, Azure Container Registry, and copy the login server. Paste it here. Then the SQL Server name, going for Azure SQL Database, and copy the SQL Server name. And replace it here. Then I will save the build without queuing the build. So let's get back to the tasks to have a quick explanation about each one. The first task is replace token, which replace keywords text files. So for example, we will replace the ACR keyword in the AKS YAML file and also the database connection string in the app setting for the web application. This includes the SQL admin and the SQL password. The run service, this is the first task for pooling the required image, which is in our case ASP.NET Core, and restoring all the third-party packages that exist in the project to that image. The next task is by building the Docker image, which has our application deployed to that image. And then we will tag the image with the build number and the latest. The third task is pushing the image to the Azure Container Registry. And publish build, this will publish the YAML file for the AKS and the DAG pack for the SQL Server on the Azure DevOps, so the release pipeline can pick them to complete the deployment. So now, if I go for the replace token, let's open a new tab, another one for the repo. So if we can see here, this is the file that is looking for, and this is the path. So if I go for the repo here and go for the web application path, looking for the app settings, you can watch this video for more information about lead time and how to measure DevOps performance and continuous delivery. And if I open the variables of the build, we can see that here the token this is the suffix and the prefix. So if I go for the variables to see the variables, so we can see, for example, here the SQL user has SQL admin. This is the value. So I need to take this value and put it in the file. And this is exactly what is the replacement token. We'll take SQL admin and replace it with SQL user, which has a suffix and prefix. So for example, if we can see here, this is the SQL user and this is the SQL password. It will be replaced by the value in these two variables. This is the SQL user and this is the SQL password. So this is the replacement token and this is for app settings. If I get back to the AKS YAML, we will see the same token prefix. Of course, I can use other prefix if I want. And this is the AKS YAML file. So let's search for this file inside the repo. So if we navigate to the file, we will find the ACR here. So this will replace by the actual name of the ACR as we copy that from our container registry. This run service that will pull the image which exists in the composer build YAML file. So let's look for this file. So as we can see, this is ASP.NET Core image, which will pull this image so we can deploy our application to that image. The next one is building the image. And this is the YAML file for the compose. Let's look for that. Here. So this will build an image called myhealth.web. This will copy the YAML and here the DACPack file. So if we go for the release, edit, we will find here in the tasks. So this is the DACPack, so I need also to have authorization. I will select that and here to make sure that it is Azure Resource Manager. Just double check, yes, the DACPack file. This is to search for the DACPack file, which will be on the Azure artifacts. And then here, I need to give authorization. Select the resource group that has my Azure Kubernetes Service. Here, my Kubernetes Service. And in the secret here, I will also give the authentication to my subscription. And here, Azure Container Registry. So Azure Kubernetes can communicate with the Azure Container Registry. The same for the second task, which update the image. Here for the secret as well. So for summary, the first task is to execute the SQL Server DACPack, and this will deploy the schema to the Azure SQL Server. And after that, it will also insert some initial data. You can see that during the build log. And then the two tasks for the AKS deployment. The first one, it create deployment and service in AKS, which will be create the load balancer in the front of the web application pod. The configuration of the load balancer to be created exists in the AKS YAML file. Then the next task, update image. This will be responsible to pull the image from Azure Container Registry. It's very important to review the animation of the PowerPoint that explain all the end-to-end of the demo so you can get better insights. So now save the deployment. I need also to update the release definition variables with the actual name of the Azure Container Registry and the SQL Server on Azure, because the release pipeline will communicate with the Azure SQL Server to deploy the DAC pack and also to communicate with the Azure Registry. So now, as we can see here, this is the variable for the deployment. Let's copy them so the deployment can communicate as well. So here I will copy the Azure Container Registry. This is the variable for the release pipeline. The previous was the build pipeline. Here's the SQL Server. And here. So now I can save the release pipeline as well, or the release definition. So now I will queue the build. So the build now is running. So as we can see, it will start building the application. Let's look for Azure Container Registry to see when it will push the image with the application. Still not. As we can see, it is in the replacement token task. Run service, this is where it's pulling the image from the public registry. Now it's building the image. Still not yet. Now it's pushing the image. As we can see, it's every change is a layer in the image, and every change is pushing differently. Now the image pushed, so if we get back here, refresh. So yes, as we can see, we have our image. And now the release is complete. The build. So this will trigger automatically the release. So if we go for the release, we can see now it's downloading the artifact, executing the DAC pack of the database, which will create the table and also creating the data, because it has the schema as well as the data of the schema. Now create deployment to Azure Kubernetes Service, updating the image, and now the release deployment complete. So if we get back to the Cloud Shell, because our session ended, then we just retrieve, we need to have the credential. So this is like login, get credential, so we can log in. And now I'm getting the pods, so I can get the IP of the pods, the running pods. As we can see here, the front end I can watch, so I can get the IP of the front end. So I will copy the real IP and access that. So now I can navigate to the web application, which is deployed to a Docker image on Azure Kubernetes Service. So if I run the command line, just show you here, and kubectl, this will not by default exist, and I can install it using Azure CLI. So this will install the Kubernetes cluster command line tool. And then I just need to add that to my environment variable. So I will add it here. This is the path to Kubernetes CLI or command line tool. Then I will run the command line now. Then if I run kubectl, we can see that it is working. And of course, I must have Azure CLI so I can install the Kubernetes CLI. And if not, I can just navigate to here and install the Azure CLI. Then install the Kubernetes CLI. So let's browse to the dashboard of the Kubernetes cluster. But first, because the service account that created to access the dashboard, it doesn't have the permission needed. So here I will create a cluster role binding using the service account. So now it's created, and then get the credential so I can log in. And after that, I will browse to the dashboard, to my AKS. So this will open a proxy tunnel. Just refresh, sometimes just to quickly open before the tunnel opened. And as we can see now, we see that the dashboard, it has 2 pods. And I can navigate to look at the web dashboard of the Kubernetes cluster. Let me show you some of the monitor capabilities. When we create AKS, we enable monitor. So let's see what does it mean. So if we go here, we can see that in the insights, we can have a full capability of the monitoring, including nodes. We have 3 nodes for this AKS. And I can navigate to the nodes. Here is the container ID. And here is the pod. And if I went for controllers, we can see also all the controllers and containers. And I can scale the AKS here 3 nodes, or I can add more and save. Or I can upgrade to a new Kubernetes version, or using here I can from the command line to scale or upgrade, so I don't have to do that from the Azure portal. I can do that as well from the command line or the Cloud Shell. At the end, I would like to thank you for watching the video. Please, if you have any question or comment, don't hesitate to reach out. You can find more information on my blog, which will appear at the end of the video, along with some other related video. Thank you.